In this video, we're going to go ahead and find the derivative of 3x squared plus 2 times x to the fifth times y cubed minus y to the fourth equals 4x. Now, this is an implicit equation because we have both y and x in the equation, but we can still use the derivative properties to find the derivative. So taking the first term, 3x squared, and finding the derivative of that, we can use the power rule. So we take the 2, pull it in front, multiply it by the 3, so 3 times 2 is 6, and then we subtract 1 from the 2 to get our new power, so 2 minus 1 is 1. So the derivative of 3x squared is just 6x. Now to find the derivative of the next term, the 2x to the fifth times y cubed, we have to actually use the product rule because we have both variables in the term. The first step is to go ahead and find the derivative of the first term, the 2x to the fifth. So to do that, we pull the 5 in front of the 2, multiply them together, so 5 times 2 is 10, and then subtract 1 from the power, so 5 minus 1 is 4. So that's the derivative of the first term, and then we multiply that by the second term, which is just y cubed, to get the first part of the derivative. Now, we have to find the derivative of the second term, which is y cubed. So we pull the 3 forward and just put it down because the coefficient of the y cubed term is 1. Subtract 1 from the power, so 3 minus 1 is 2. So the derivative of this second term is 3y squared. And then because we're finding the derivative of the y term, we do have to multiply this term by dy over dx. By the first term, which is 2x to the fifth, the 3 times 2 just becomes a 6. This makes the derivative of the second term 10x to the fourth times y cubed plus 6y squared times dy over dx times x to the fifth. Now to find the derivative of the next term, the negative y to the fourth, we can just use the power rule, bring the 4 over and in front, and then subtract 1 from the 4 to get the new power. So the derivative of this term is negative 4y cubed. And since our variable is y and not x, we do have to multiply it by the dy over dx. Taking the last term, the 4x, to find the derivative of that is just 4. Now that we found the derivatives of each of these terms, we can go ahead and solve for the dy over dx, because that's what the derivative, the change in y over change in x, is. So we can do that by first isolating the dy over dx on one side of the equation by subtracting 6x from both sides, and subtracting 10 times x to the fourth times y cubed from both sides. Now, dy over dx is in both terms on the left side of the equation, so we can go ahead and factor that out, leaving us dy over dx times the quantity of 6y squared times x to the fifth minus 4y cubed. And dividing both sides of the equation by that allows us to isolate our dy over dx and gives us what the derivative of the function is.